First, let's open our document. So here is our Docker workshop. In this Docker workshop, so we are reaching to the concept of how to Dockerize a Spring Boot application today. And before that, we just started our discussion to understand about how to create a Docker file and how to create a Docker image, and then how to create a Docker container using that image. So in the last session, I have explained about what are the instructions. They're also called as what are the keywords to be used in order to Dockerize, to define a Docker file. To create a Docker image, we need a Docker file. And to write the Docker file, you need to have some instructions. They are called domain-specific language instructions. So we started our discussion with the Docker file. And in the Docker file, we have discussed about these are the different Docker keywords are available, Dockerfile keywords from maintainer, copy, add, run, cmd, expose, entry point, and work dir. In the previous session, I just have explained about how to work with some of these from container, add, difference between copy and add, then some run instructions and cmd instructions. Okay, this is how I have explained up to cmd. And today we are just going to discuss remaining. Then we are going to discuss about how to Dockerize a simple Spring Boot application without any database support. Then we'll see what is Docker Compose. Then next we are going to look into how to Dockerize a Spring Boot application with Maven as a with MySQL as a database. So first today we want to discuss about the remaining. Here we'll be having something called as expose, entry point, and work dir. These are the remaining the Docker keywords, the keywords of Dockerfile that we need to discuss. So first I'm going to talk about expose. Actually, expose is a one Docker command, or we can say one keyword that is used to specify the port that is used by container. It is used to specify the port that is used by the the Docker container. So within the container, we know that application will run. The application port number within the container can be specified by using expose. But one thing, by using expose command, when you write any particular port number, that is just like a documentation, which means if I change the port number in expose, it is not really going to change the port of the container. It is not really going to set the port for the container. Just on which port number that my container I am going to start, that we can write by using expose. Just it is a kind of a documentation instruction. Okay, it is just only a documentation instruction. It is going to tell about which port the container is using. That's it. But if we change the port number, container port number will not change. If we change the port number, container port number will not change. To remember that. So it is just only for documentation purpose. Suppose if I write expose 8080, we are talking about expose. And you know, all these Docker keywords are in uppercase letters in a Docker file. Okay, it is very simple. Expose, okay, which is a documentation command. It tells about which port number the application uses within container. It tells about which port number, which port the application uses within a container. Within container, my application will run. My web application, my Spring Boot application, right? Or my database server application. So they run within container. So it tells about which port the application uses within a container. Okay, right. But one thing, this is only a documentation purpose. This is This is just for documentation. This is just for documentation. What does it mean? It means if you change the port, if you change the port with expose keyword, we change the port with expose keyword, the application port in container does not change. Application port within the container, the application port within the container does not change. Doesn't change. Right? Okay. Application port within the container does not change. Okay. This is just for documentation. It means if we change the port with expose keyword, the application port within the container does not change. That's called expose keyword. It is only just for documentation. Okay. Example, we write like this: expose 8080. Okay. If I write, for example, expose 9080, it doesn't mean that container is going to start on 9080. Within the container, application does not start with the port number 9080. Just it is only a documentation purpose. What port that application uses within the container, that you are writing here. But it doesn't mean that if you change the port number here from 9080 to, for example, 8080 to 9080, it doesn't mean that application is not going to start on the port number 9080. Whenever you are going to run the Docker image, you are going to specify a Docker container will be created, right? So at the time of starting the container, at the time of creating the container, we should do the port mapping by using -p. So that I'm going to explain you. But here, just it is only a documentation purpose. There is no, it doesn't mean that if you change port number to 9080, then container is not going to run on port number 9080. Okay, it will run on its port. That port we are going to specify when you run the Docker run command. It is just only for documentation purpose. With which port you are going to start the container, that port number you are writing here. That's it. It is only just for documentation purpose. Okay, there is nothing like that. This is only for documentation. If you change the port number here, it really does not affect the application port within the container. That is called expose. Next one that we want to discuss is entry point. Next one is called entry point. Actually, entry point and CMD both are for same. Next one is entry point. Entry point instruction will execute when container is started. CMD command also will execute the instruction when a container starts. So CMD and entry point, both commands will execute the instruction when container starts. CMD instructions are not executed while creating an image. Similarly, entry point instruction also not executed. Entry point instruction also not executed while creating the image. So like a CMD, we have entry point. Like a CMD, we have entry point. You have to understand this. Well, like a CMD, we have entry point, right? But the difference is CMD instruction can be overridden at the time of executing the image by passing like an argument. CMD instructions can be overridden. CMD instruction given in Dockerfile. But at the time of running the container, when container starts, during the container start time, we can override the CMD instruction by passing the CMD. But entry point instruction cannot be overridden. Entry point instruction cannot be over. That's the difference between CMD and entry point. Now we are looking forward to understand about how to use entry point. We are looking to understand about how to use entry point. Let's start working on that. Okay, right. Understand the point here. Okay, right. Simhadri, somebody, okay, started typing message. Tomcat container or Docker container? Docker container does not have a port. Within the container, your application will have a port. That is the answer for your question. Okay, I'll answer questions later. First, let's continue. So entry point, okay? Entry point. So what is entry point? Entry point and CMD. Entry point and CMD. Both are the instructions that are executed. Both are the instructions that are executed while starting when container starts, but not while creating the image. Okay, right. Understand the point clearly. Okay, right. Understand the point clearly. Okay, right. So, but remember, entry point instruction is fixed. It cannot be overridden. It cannot be overwritten. Okay, and it cannot be passed at runtime. But CMD instruction can be overridden, can be passed at the time of starting the container by using option called --CMD. So, for example, first let me talk about this point. Entry point instruction I want to write. Same entry point keyword will execute the instruction when a container start, not while creating the image. Not while creating the image. The same points, but I just want to remove this. I want right here. This is entry point. This is entry point. This is entry point. So entry point keyword will execute instructions when container starts. Entry point instructions are not executed. Entry point instructions are not executed while creating an image. While creating an image. Okay, while creating an image. Right. Now, entry point instruction cannot be replaced, but CMD instructions can be replaced. Okay, whenever we are starting the Docker container. Okay, I'll tell you how it is going to be. Entry point is like a CMD. Entry point is like CMD, but entry point cannot be overridden, while starting the container. While starting the container. Entry point cannot be overwritten while starting the container. See, for example, I'm writing like this now. Example, suppose I have an image, consider it is a first image. So I'm going to run the container like this now. Docker run image. When you run the image, container is created. When you run the image, container is created. Docker run. Okay, then your image, for example, first image. For example, first image. And you are passing something like this, a flag, --CMD space, --CMD by using --, flag, --CMD flag, and you can write some instruction here. So whatever is there in Dockerfile, that will be overridden with this instruction. For example, hello, I am from, okay, I am from CMD flag. Hello, I am from CMD flag, something like that. By using --flag CMD, by using CMD flag, I can overwrite the instruction that is available in Dockerfile. But for entry point, it is not possible. For entry point, we cannot overwrite by using flag. This type of flag is not allowed for entry point. Entry point is like CMD only, but that there is a difference. Hope you are understanding about the difference between them. Next, how to write entry point instruction. Okay, right. Look at this. Now, within a Docker file, in a Docker file, entry point instruction can be written like this. In a Docker file, in a Docker file, entry point can be added like below. How do you write this? Entry point. Then you have to specify. First one is executable. Then you can pass parameter 1, parameter 2 like that for that executable. If any parameters are required, you can specify the parameters. Of course, you can add parameter 1, parameter 2, and so on within square bracket. This is a way of writing the instruction called entry point. Okay. Now, you can add multiple entry point instructions also in Dockerfile, but only the last one will work. You can add multiple like CMD only. You can write multiple entry point instructions in a Dockerfile. But only last one will execute. Only the last one will work. Only the last one will work. Entry point, executable, param1, param2, so on. Like that we can specify. Okay, right. For example, I'm writing like this. Example, entry point, space. Then I'm writing Java is executable. -jar is first parameter for this executable. Next one, for example, my web app.jar is the second parameter. So Java is executable. -jar is the first parameter for this executable. My web app.jar is the second parameter for this executable. Now I'll be having entry point space Java -jar my web app.jar. This is how it works. Now this is my entry point command. Okay, the entry point keyword. Last one is work dir. Last one. It is just to set the directory within the container for the next steps. So work dir is to specify the working directory or directory inside the container for the subsequent steps. That's what the meaning of work dir. The last one, work dir. We are discussing it as last. It doesn't mean that you must write this instruction as the last in the Docker file. It's not like that. We can write anywhere in the middle as well, but this instruction is to set a home directory within the container for the subsequent steps. So means after work dir instruction, whatever the following instructions are there, all those following instructions are executed from that work dir. That's a home directory for following instructions. After work dir within the Docker file, whatever you write, whatever method, maybe you're writing entry point, or maybe you're writing expose, right? Or maybe you are writing CMD, whatever, right? So all those subsequent steps will use this working directory as a home directory inside the container. That's what the meaning of writing work dir. So what we will do at the time of Dockerizing our Spring Boot application today, we are going to first keep or copy the jar file of our Spring Boot application into some working directory. And then we are going to set the working directory as that the directory in which my jar file is available. Then we are going to run the entry point instruction. So when you are writing the Docker file today, you are going to understand about importance of work dir. Okay, right. So what is the purpose of work dir? Work dir keyword. Work dir keyword can be used to set home directory within the container, home directory within the container for subsequent steps. That's the purpose of work dir. So we are going to set, this is called work dir, means working directory. Okay. What does it mean? After working directory set, if you write any copy, add, entry point, cmd, run in the Docker file, so all those instructions are getting executed from that work dir. So it will set a working directory. It will set a working directory, and after this instruction, if you add any run, cmd, okay, copy, okay, otherwise add, entry point. If you add any run, cmd, copy, add, entry point instructions, if you add any of these run, cmd, copy, add, entry point instructions in the Docker file, then all these instructions are executed from that working directory. All these instructions are executed from that working directory. All these instructions are executed from that working directory. That's what the meaning of setting the work dir. Okay. Next. Now we got to know about all these, how to write the Dockerfile instructions. And now it is a time to discuss about how to Dockerize our Spring Boot application. We'll take up one small Spring Boot application. We are going to create one Spring Boot application now in IntelliJ IDE. Then we are going to create a Docker file. Then we are going to build a Docker image. And then we are going to run the Spring Boot application as a Docker container. So that is what we are going to discuss about, how to Dockerize a Spring Boot application. That's what our current discussion now. After knowing about all the Dockerfile instructions, now we are going to discuss about how to Dockerize a Spring Boot application. We want to understand about how to Dockerize a Spring Boot application. So what we are going to do now, first we are going to create one small Spring Boot application in IntelliJ. One simple Spring Boot application with some simple REST controller class we are creating with 1 or 2 endpoints we are going to define in that. And once it is done, then we are going to package the application into a jar file. And once it is packaged into jar file, my source code is available. And once my source code is available, next we are going to create the Docker file in the project directory. Always we need to keep the Docker file in the project directory so that the code and the related Docker file, both we can see at one place. So creating Docker file in the project directory. Once we create the Docker file in the project directory, so the next we are going to build the image. Once we build the image, then we are going to run the image. So the Docker container starts. Docker container starts. So once it is done, if we push this image to Docker repository, it is not mandatory to push it, but suppose if I want to share it with you so that you can also test my application, I can push it to my Docker registry and you can pull it and you can execute it, and you can also run the Docker image in your machine. So Docker container will start and you can send a request. Okay, in the browser, you can able to send a request, or from Postman, you can send a request and you can see the response. So we are now discussing about. So here we are going to create the Docker image. Then we are going to start the Docker container for our Spring Boot application. And then we are going to test it from browser. So that is the first application that we want to discuss. That is called Dockerizing our Spring Boot application. Actually, here source code is also available in my local machine only. I mean, I am only creating within my IDE. If the source code is available in GitHub repository, for example, then what should I do is I need to first clone the repository by using git clone command. Now I'll get the source code into my machine after cloning that repository. Then I will use Maven. First, I'll clean install option is there. Maven build lifecycle. So once if I say Maven clean install, then a jar file is created for my Spring Boot application project in the target folder. After that, I'm going to create one Docker file. Then I'm going to create a Docker image. Then I'm going to run it as a Docker container. But here, source code also I'm only creating within the IntelliJ IDE. So instead of cloning the repository by using git clone, source code is available in my machine itself. Of course, I'm going to create that code now. Next, I'm going to prepare the Docker file. I'm going to tell you how to prepare the Docker file for that. And then we are going to build an image. So then we are going to run the image so that Docker container will be created for the Spring Boot application. So we are going to discuss about steps to Dockerize a Spring Boot application. Steps to Dockerize a Spring Boot application. A simple Spring Boot REST application, of course, without using any database. Next, we'll see with the database, but currently for today, we are not going to use any database. So we are going to discuss like this: Dockerizing or creating a Docker image for Spring Boot application. Creating a Docker image for Spring Boot application. Creating a Docker image for Spring Boot application. Spring Boot REST application. Okay, we want to create a first Spring Boot application using IntelliJ. I'm going to create it now. I'm using IntelliJ. Creating a Docker image for Spring Boot application. So what are the steps that we are going to do now? First, we are going to create the Spring Boot REST application. Overall steps. First, prepare a Spring Boot REST application. That's the first thing. Prepare a Spring Boot REST application. Spring Boot REST application. Prepare a Spring Boot REST application. That's the first step. Prepare a Spring Boot REST application. Second step is create a jar file or build the application to create a jar file or var file. Create a jar file. Create a jar file using Maven. Create a jar file using Maven, and you know the step like how it can be done. Next, once you create a jar file using Maven, now create a Docker file. Create a Docker file in the project. Create a Docker file in the project. First, you prepare the jar file, then you need to create a Docker file. Create a Docker file in the project. So after creating the Docker file in the project, now you need to prepare image. You build an image for the application. First, you build an image, build a Docker image. Build a Docker image. Now execute or run the image. Now run the Docker image. High level steps are 5. At high level, there are 5 steps. Prepare a Spring Boot REST application. Create a jar file using Maven. And after that, create a Docker file in the project. Next one is build a Docker image. Now run the Docker image. After running the Docker image, we will see how to push this into remote repository. Nothing but Docker registry, the public registry. If it is pushed into registry, I can store there. And whenever I want, I can pull from there. Or even if you want, you can also pull it. And you can also run my application using Docker without writing the source code and without worrying about dependencies and all these things. So now the first application in which we are not using any database, without database, just only a simple Spring Boot REST application we are going to create. And we want to create a a jar file using Maven, create a Docker file in the project, then build a Docker image and run the Docker image. Okay, let's start doing this. First, I want to start IntelliJ. Next, before I start IntelliJ, first I want to download, or I want to first generate the skeleton of the Spring Boot REST application. Skeleton of the Spring Boot REST application. I'll go to, the steps. First, you have to open Spring Initializer tool, start.spring.io. Spring Initializer tool, start.spring.io. Okay, now I'm choosing language Java, project Maven. I want to use Spring Boot version 3.5.9. Group ID in.ashok IT. In.ashok IT. Artifact ID, it could be any name. Let's say Spring Boot Docker app. I'm just taking my name as Spring Boot Docker app, or it can be any name of your choice, doesn't matter. A sample application, something name like that. Then package name in.ashok IT. Okay, artifact ID is Spring Boot Docker app. Package name is in.ashok IT. Packaging is jar. And configuration YAML file I want to create. It could be YAML file or properties file, any one of your choice. Any one of your choice. We are getting a REST application. And Java version, you can use anyone. I'm using 21. Next, dependencies. Dependencies. I can add web dependency. The only web dependency, and I don't want any other dependency except web dependency. Just I want to add only one dependency, that's called Spring Boot Starter Web Dependency. And then I just want to click on generate. Now, a zip file is downloaded. You extract the zip file into the location where you want to place it. The location where you want to place, that's up to you in your system. I don't know which folder and which workspace you are using, but you can simply place there. Now, once my extraction is completed, now it's good to go with IntelliJ. So first step is we are going to prepare the Spring Boot REST application. So just we are going to create one REST container. Let's see. REST controller class we are going to create. So first let's open IntelliJ. Now in IntelliJ, first we want to load this project into IntelliJ IDE. We'll wait for IntelliJ starts. Okay. Now I first want to load it. Open. File open. I'll go to my location where you'll be finding something called Spring-Docker, Spring Boot-Docker app. Open this. Now it is resolving the Maven dependencies, and finally my application is loaded into this IntelliJ IDE. It is resolving the Maven dependencies. Once resolving the dependencies is completed, then I will start. Just I'll open form.xml to show you what are the dependencies included. Spring Boot Starter Web Dependency. And we are going to create one simple REST controller. And then we are going to Dockerize this application by creating a Dockerfile. So here, this is form.xml. In this form.xml that you can see here, Spring Boot Starter Web is the only dependency that I have included. And of course, whenever you create any Spring Boot application, automatically this test is also included, but we are not defining any test cases. Spring Boot Starter Web dependency is included, and this is enough for my application for creating a simple Spring Boot REST application. Next. Now I'll open SRC folder. I'll go to main. Under Java folder, you can see there is one Spring Boot Docker application. The main class is created. This is Spring Boot application main class, and you have added Spring Boot application annotation. Now, I want to create one REST controller class. So I want to create a new package first. Right click on in.Ashok IT, create a new package. Let's start creating a new package. Package name, simply API. So there is a new package I created, in.ashokit.api. That's the package. In this package, I'm creating one new Java class. And consider my Java class is it could be any sample controller, something like that. I'm creating one controller. This is just to Dockerize our Spring Boot application. And we want to know, like, can we make a Docker image for our Spring Boot application or not? So for that, I just want to write some controller class. It could be any controller. Let's say, for example, hello controller. Hello controller. It's a REST controller class. Hello REST controller. Okay. Now first we are going to make it as a REST controller class by using annotation at REST controller. By using annotation at REST controller. Next, here I'm writing one simple endpoint. I'm going to define one simple handler to handle a path of this application. So at get mapping, the value equal to /hello /name. Now this is the URI variable, which is also called path variable. And I want to define a method like this: public, return type is string. The method is hello method. And I'm just going to map this variable to this method argument. So to map this variable to the method argument, then we have annotation called @path variable. These are all from Spring Boot, as you know. Just it should return hello for that username, for that name. Just I wanted to return hello plus name plus comma. Welcome to Spring Boot with Docker. Spring Boot with Docker app. Hello, welcome to Spring Boot with Docker app. Name comes in the middle. Okay, if the name is Miller, hello Miller, welcome to Spring Boot Docker app. Like that. This is only one endpoint I'm creating in REST controller. Now, once the REST controller is created, I'm not creating any service class, or I'm not writing any repositories, nothing. Just a simple REST application. Only one endpoint it has. And there is only one handler that can be able to handle a single path, that is hello /name. So this is the path. This is the path that is mapped to this handler. Okay. So now there is only one endpoint is created in this REST controller. Now once the REST controller is completed, now go to resources folder. In resources, you can find application.yaml YAML file. And here you can configure the server port. Because it's a Spring Boot application which has embedded Tomcat as by default. the server. So our application itself embeds the server, and to start our application on a port, we need to specify the server port. So server port, it's YAML configuration. So server port, server.port, server port space, and you know how to write YAML file. So now here, I just want to specify the server port is actually 8080 I can use. That's a default port actually. If you don't specify the server port, by default runs on port number 8080 only. Okay, for example, I want to run on port 8082. 8082. That's a port for my application. Within the container, my server is going to run on port number 8082. 8082. Okay. Next. Once you configure this, then you are good with your application. And now you need to prepare or you need to build a jar file for this application. After creating the jar file, then you need to create a Docker file. And Docker file also must be created in the Spring Boot Docker app only. So how can I do that? I can do one thing. If I want to build this Spring Boot Docker app, if I want to package this application into a distributable file, that is jar file. So first go to Maven. You can see the cursor over there, Maven. And here you just expand this application, Maven application Spring Boot Docker app, the project. Now this project is containing lifecycle. And in this lifecycle, I am going to specify package. I want to execute this goal that is called the lifecycle phase called package. When I click on package, automatically clean, validate, compile, test, everything will execute up to package. So just double click on package so that a target folder is created. Within the target folder, then there is a jar file created. Spring Boot Docker app jar file is created. Okay, let's double click on package. Let's double click on package. Right? Are you getting my point? Right. Now I got a build success. After getting the build success, now you can see, just open the target folder. You can see that there is one jar file created called Spring Boot Docker app hyphen its version 001 hyphen snapshot dot jar. Spring Boot hyphen Docker hyphen app hyphen 001 hyphen snapshot dot jar. Now my jar file is ready. Now so far these are the steps we have completed. First, preparing a Spring Boot REST application, then creating a jar file for using Maven by using Maven lifecycle, that is package. The first 1 and 2 steps are completed. And the third step is we need to create a Docker file in the project. We need to create a Docker file in the project. After creating the jar file, then you need to create a Docker file. Okay, the file name must be Dockerfile. The file name must be Dockerfile. If you change the file name, then we have to pass the file name as a parameter when you are creating an image. I'll show you that. But mostly we are going to use the file name as Dockerfile. And we are also going to keep the Docker file within the project folder only, so that it will be good for everyone to see the Docker file through which the image was created. Okay. So what we are going to do now? Now we are going to create. Okay. Now we are going to create Docker file. File does not have an extension. File does not have an extension. New file. Within the project directory, create a new file. File name is Dockerfile. Decapsulated Dockerfile. No extension like .txt, nothing. Dockerfile, that's it. Dockerfile. Now this is Dockerfile. Now this Dockerfile should contain instructions. That instructions are executed from top to bottom to build an image. Some of the instructions are executed while creating the image. Some of the instructions are executed while running the container. When you start the container, when you run the image, container is created. When container starts, CMD instructions, entry point instructions are executed while starting the container. When container is started. Okay. First, I'm going to write in the Docker file the first instruction. First, we need Java 21 to run my source code, my Spring Boot application. Okay. I need Java 21. It's already built like a jar file. To run the jar file, I need Java, executable Java. Jar is ready already. Again, Maven is not required. Already through Maven, my project is built. The source code is built like a jar file. Now I want to execute the jar file. To execute the jar file, I need Java software because Java is an executable with option -jar. So it is built on Java 21. So first, whenever we are creating our image for our project, it uses some base image. So base image is Java. I need Java as a base image. That too, Java 21, I want to use like a base image. So from use a base image as JDK 21. I'll tell you. I'm writing just like a comment. Use a base image. Comment we can write with hash as Java JDK 21. The first instruction is from space. From space. Now base image. The base image for 21. The base image for 21 is public image. Eclipse-tmorun :21 -jre -alpine. So this you need to first search. This is a first image from Eclipse-tmorun 21 jre alpine. This is for JRE 21. I mean JDK 21. This is official image. Okay. You understand the point clearly now. Okay. Right. Okay. Right. See, why I'm using only JRE, why not JDK? Because my source code is already compiled. Within the container, jar file is there. Just I need to run the jar file. To run the jar file, I need JRE. I don't require JDK. If I include JDK, for example, here, then JDK comes with JRE as well. But my image size gets increased. My image size gets increased. That's why, because already I have a jar file. Just within my container, I need a JRE, Java runtime to run my application. JDK is not. JDK is for development. But applications are developed. Jar file is already available. Just only it should run the jar file. To run the jar file, there is a JRE. So JRE is required, but not JDK. So that's why I'm writing Eclipse-tmorun 21 -jre alpine. This is the official image for 21. Okay, this is going to reduce my image size. If I add JDK, then the base image will be part of my image. So then obviously what happens, my image size gets increased. So that's why instead of using JDK, I'm going to use JREL, because only to run my application within the container, my application should run, but I no need to compile my source code. JDK is not required because already application code is compiled. Application is prepared like a jar file. Just only the jar file should be executed by using JRE. So from eclipse-turmeric :21-JRE-alpine. That is the first instruction. That is called from instruction. Next one. Now, I'm writing copy the Spring Boot jar file. Just I'm writing comments, Spring Boot jar file into the container. Into the container or into the image, whatever. Of course, you know that first image is created. Then when you run the image, container starts. So copy the Spring Boot jar file into the image or into the container. Any word is correct. Into the container. Then we know the instruction name is called copy. If you want to write maintainer, maintain instruction also we can write. For example, maintainer. Maintainer means who has written maintainer of this Docker file. Maintainer of this Docker file. I'm writing something like this. Maintainer. Maintainer. For example, I'm writing Shaker. For example, Shaker at ashokit.in. It is just only documentation purpose. That's it. Who is a maintainer of this Docker file? That's it. Now copy the image, the Spring Boot jar file into the container. So where is my Spring Boot jar file? My Docker file is within the project. My Docker file is created within the project directory. But this jar file is there in target folder. In target folder, the jar file name is Spring Boot -docker-app -001-snapshot.jar. Okay, so I'm writing instruction like this. Copy target // Spring Boot target / Spring Boot -docker-app -001-snapshot.jar. This is my jar file name. And copy into a directory in the container. Any directory within the container, doesn't matter. So for example, within the container, I'm saying that copy it into /usr/app. /usr. USR means user, current user.